our PNG 332 online class. Today we are going to cover the first chapter of the book, which is the components of naturally occurring petroleum fluids. As a petroleum engineer, we are interested to know the compositions of the oil and gas that we are producing and their behavior and their properties, and we want to know at what conditions this product will be stable, at what condition it's going to be reactive, and we want to be able to name these components. And obviously, exactly like the other industry and the other products, anything that we want to sell, we need to know its properties, how to name that, the applications, the safety. It's very similar to other products. When you go and shop anything, at the back of the whatever that you're buying, there are instructions, there are components, there are directions, and everything. So here is the same. As a petroleum engineers, our product is the oil and gas, and therefore we need to know its properties and naming, and and all the behaviors about that. Generally, when we are talking about the behavior of oil and gas, we are going to define those at specific conditions, because a very specific component and mixture could behave differently at different conditions. And with conditions, what I mean is at what pressure, at what temperature, and what volume. Okay, so these are very important. And anytime that we refer to the state of a component, we need to also mention at what pressure, what temperature this has been measured. So today what we are going to do, we are going to start with the components of typical petroleum, gas, and liquid. And then we are going to cover a little bit of organic chemistry and structural theory and chemical bonds. I know these parts should be also already covered in your organic chemistry, but because of the unconventional reservoir development and all that, there are lots of applications in the oil and gas industry nowadays that depends on the good understanding of these chemical properties. Okay, so that's why we need to basically revisit this and refresh our memory regarding the behavior of the organic materials and their structures. And then we are going to look at the representation of these structures. And then we move to the hydrocarbon components of petroleum fluids, how we divide them in different groups, what are the non-hydrocarbon components, and at the end we define two very important components of the oil, which are resins and asphaltenes and their chemical classifications. Okay, so starting with the major source of organic material, major source of oil and gas, it's basically the organic materials. Okay, in most of the oil and gas reservoirs, the major source is the organic materials, which is basically coming from the decay of the living organism through time and because of the high pressure and high temperature. Okay, generally coal and petroleum are two major sources of organic materials. Okay, they are products of plants and animal decay, as I said. However, in addition to these sources, the organic source, there are large size volcanic petroleum reservoirs as well. Okay, that has been discovered in many countries around the world. Okay, so these volcanic reservoirs are definitely not from the organic materials, because we don't have a sedimentary rocks, that bury that the animal parts or the plants has been buried under and all and the rest. But in the case of volcanic reservoirs, we do have the components. We know the components of oil and gas, right? It's carbon, hydrogen. So if you have a carbon element and a hydrogen at the right pressure and right temperature, okay, you can also produce oil and gas. This is something that people sometimes do in the lab to test. So we believe these reservoirs, these volcanic reservoirs, are basically coming from having these elements at the right pressure and right temperature. Okay, but majority of the oil and gas reservoirs are organic based. Okay, and we are going to study those during this class. So, as a petroleum engineer, our responsibility, again, as I said, is to know the product that we are going to sell. Okay. So, we need to know how to name those products, we need to know how to differentiate them, define different types, and we should be able to define their behavior and relationships to one another. What's the degree of volatility, what is the degree of reactivity of these components, and so on and so forth. So we need to know all about this. When we know all about our product, then we need to do something to maximize, our benefit. We are going to sell. So how you can sell this to get the maximum benefit for your company, and that becomes the next discussion of in this class. Okay. But generally, let's look at the components of the natural gas well and the gas well that's going to produce some liquid. We know at a specific condition, like at the room temperature, okay, and pressure, generally from the organic chemistry, we know that we will have a gas phase if the molecules are small, and we will have a liquid phase if the molecules are large. So as we having larger and bigger molecules and components, we expect to have more of a liquid phase. As we have smaller components, we expect to have the gas. Okay. So if we look at the components of the natural gas, as you can see, this is very typical in the natural gas reservoirs, which methane, which is the simplest and the lightest hydrocarbon component, basically the natural gas contains 70 to 98% of the natural gas is made of methane. Okay, so methane takes 70 to 98% of the natural gas component, and you might have 1 to 10% of ethane, and 0 to some traces mean zero, very small amount of propane to 5% propane, and very small amount of butane to 2% butane. So here are the hydrocarbon components, and the rest of the hydrocarbons are less than 1%, okay, or they're like just traces if they are in the natural gas, okay. In the case of non-hydrocarbon components, this is also very important. It could be negligible, up to 15% nitrogen, or 5% carbon dioxide, or 3% hydrogen sulfide. Okay, so these are also very common non-hydrocarbon components, and we also need to know their behavior, because some of them are basically we don't want them. They're problematic, like hydrogen sulfide. If you have it in your natural gas, it generates lots of problem due in the processing. Okay, due to this corrosive properties of the hydrogen sulfide. Okay, so if I have a well which is a natural gas, generally dry natural gas, up to 98% is methane, and the rest of ethane, some propane, some butane, and then some maybe very small amount of non-hydrocarbon components. However, if I move to the well, which also produces some liquid, okay, we call them like wet gas reservoirs. We will go over this when we go to the classification of the hydrocarbon fluids. So in these kind of reservoirs, as you can see, the methane, which is the lightest, smallest component of hydrocarbon component, drops from 70 to 98% in the dry gas reservoir to 45 to 92% in the wet gas reservoirs. Okay, and heavier component like ethane, propane, butane. So as we go down the list, the component becomes heavier and the molecules becomes larger. So they start going off from 1 to 10 to 4 to 21%, from 0 to 5 to 1 to 15%, from 0 to 2 to 1 to 7%. Okay, and it's going to be the same for the nitrogen as the non-hydrocarbon components as well. So the non-hydrocarbon components are very similar in both cases. However, the hydrocarbon components, when we go from the dry gas reservoir, which is a gas only phase, to the case where we can produce also liquid at the surface, then the components, the heavier components, starts kicking in to the components. Okay. What about the crude oil? So that was the gas. If we go to the crude oil, A typical crude oil contains thousands of gases and liquid phase chemical components. Okay, so it's very important to define a crude oil in terms of its fraction. What's the fraction of light components and the heavy components, and what's the boiling point of these components? Because in the separation tower, we are going to break these crude oil, and we are going to separate these components and at different stages of the processing plant. And obviously, we do this because we can sell this at a different price, okay, at different every part of this crude oil, every component will have a different application, so we can sell it differently with different price, okay. So it's not like the old days where the countries like, let's say, in Middle East, they were just producing crude oil and they were selling it as crude, and then other countries were like buying these products and then using the fractionation and then using the processing and then turn it to the different products and sell it to them even more expensively than what they bought at the first place, okay. So it's very important, again, as a petroleum engineer, since this is our product and we are going to sell that, to know the value of our product and to know how we can maximize the benefit of our company. So if you can see in this table, from the light components, C1, C2, this is basically the carbons. These are number of the carbons. C1 means you have one carbon atom. C2 means you have two carbons. And then it goes all the way. So as you have more carbon in your structure becomes bigger and heavier, okay? So as your structure becomes bigger and heavier, then you need more energy to break those structures. So the boiling point, starts going up, okay? So we can separate these components based on their boiling point, and in the fractionation plant, we can separate them and we can use them for different purposes, okay? And basically this way, we can get the maximum benefit out of our product, okay? Element-wise, if we look at the elements of the hydrocarbon components and petroleum and gas, we can see more than 95% of the oil and gas reservoirs, element-wise, consist of carbon and hydrogen, okay? So carbon and hydrogen is more than 95% of our product. And then we'll have some sulfur, nitrogen, and oxygen, okay? So these are plain non-hydrocarbon components, okay? So more than 95% of our elements are carbon and hydrogen, and then we have some sulfur, nitrogen, and oxygen. This carbon and hydrogen, okay, like a bonding of CH2, carbon has 4 bondings, right? And the hydrogen is 1, okay? So a carbon with two bonds of hydrogen and 2 empty bonds is a major block of any hydrocarbon structure, because it can start generating chains. It can start bringing different CH2 groups together to generate a large hydrocarbon components, which we will go over these structures in the part 2 of this first lecture video.